In this lesson, we're picking up several new vocabulary terms, notably range, the quartiles, and interquartile range. We're also going to talk about box and whisker plots, which is something that I'm pretty sure is covered in like 7th grade math. It's something you guys haven't seen in a long time. It's really simple. We just need to take a look at it. So first of all, the range. The range of a set of data is simply the difference between the minimum and the maximum data points in your set. Now that doesn't mean the range is like, quote, from 2 to 17. It means you literally subtract those things, right? Like if your minimum point is 2 and your maximum point is 17, then the range is 15, right? It is literally a measurement of how the difference between the minimum and the maximum data points, okay? The next vocabulary term are quartiles. The lower quartile marker, which is denoted Q1, is the median of the lower 50% of the data. Right? The upper quartile marker, which is called Q3, is the median of the upper 50% of the data. So practically speaking, what that means is, like, let's say you've sort of got a whole set of data here, right? The median is going to be in the middle of the data. If you put them all in order, this is going to be the median, right? The first quartile is if you look at only the bottom half of the data, the median of that is Q1. Right? Similarly, if you look only at the top half of the data, the median of the upper half is called Q3. And we'll look at those in an example in just a minute. But Q1 and Q3 are basically the median of the lower half and the median of the upper half. Finally, interquartile range is kind of the combination of these two things. A lot of times they'll write it as IQR, interquartile range. It's just the range between the lower and upper quartile markers. In other words, if you want to find the interquartile range, you just do Q3 minus Q1. And it's the same deal as the range up above. They don't want to see like, oh, you know, it's between 2 and 7. They want 7 minus 2 is 5. The interquartile range is 5. Okay? So the next thing I want to talk about is a box and whisker plot. So we're going to sort of go into that and then we'll get to some examples. So I think here I kind of just want to show you, like, so what does a box and whisker plot look like? Well, the reason it's called a box and whisker plot is that there will be a box with a line in the middle of it, and then there will be, you know, lines that come off the end of this thing that are supposed to resemble whiskers, I guess. And the idea is that, imagine that your data starts here with a minimum value and ends here with a maximum value, right? The value right in the middle would be the median. And then as we mentioned before, the thing that's halfway between the minimum and the median is the first quartile, and the thing between the median and the maximum is the third quartile. And the idea behind these things is that they're supposed to be done to scale. So let me sort of give you an example. Suppose we had a number line that went from like 0 to 20. If someone drew you a box and whisker plot that looked like this, let's see, so this is like 0, and then let's say this is 10, 11, 12, 20. What does this box and whisker plot tell you? And this is actually fairly important, so make sure you're paying attention for this, right? This means, like, the thing about box and whisker plot is that 25% of the data falls in each one of these little ranges, right? So it means, like, if there were, 100 people that took this test or whatever, 25% of them got a score somewhere between 12 and 20. These scores are really spread out, right? It also means that 25% of the population, 25 people, got scores between 11 and 12. So there were a ton of people that got, like, either 11 or 12 or 11 and a half or something. Whereas in here, I mean, we might not have had anybody that got a score of like 13 or 15 or 17. The idea is the wider one of these things is, the more spread out the data is in that area. I don't know if that makes any sense. I don't know that the IB exam is going to ask a whole lot conceptually about these things. A lot of times what they're going to look for is, can you label the diagram? Can you tell them what the minimum, maximum, first and third quartiles are, and what the median of the data is? So with that said, with a quick diagram about how to draw these things, we'll now move on to some examples about how to compute the things that we talked about on the first slide, and maybe even drawing some of these box and whisker plots. So my first example, find the minimum, median, and maximum of the following data. So let's just start with that, right? First of all, what is the minimum of the data that we have here? Well, I was kind enough to put this in order for you, so hopefully you can see that the minimum is 0 and that the maximum is 10. Right? The other thing they wanted in there was the median, right? And how do I find the median? Right, well, we've talked about this idea that it's sort of the middle number. So one way we can do it is sort of to count down from the outside and find what the middle number is. The other way to do it is actually to count the numbers. If you've got 1, 2, 3, 4, 5, 6, 7, 8, 9, you've got 9 numbers here. If you average together 1 and 9, 1 plus 9 over 2 gives you 5, it means the median is going to be the 5th number, right? So if I count these out, 1, 2, 3, 4, 5, this is the median. So the median for us is 7. Okay. Then it's asking for us to compute the quartile markers. So in other words, they want us to find Q1 and Q3. Right, so how do we do that? The idea is you look at the lower half of the data and the upper half of the data. So to find Q1, I'm going to look at the lower half of the data. By the way, because 7 was actually the median, we don't use it like in splitting this in half, right? So this is going to be the lower half of the data, this is the upper half of the data. So Q1 is the median of this lower half of the data, right? So how do I find that? Well, kind of go halfway in between. Your median is going to be right in between there, which means for us, Q1 is the average of 3 and 5. 3 plus 5 over 2, that's 4. Right? Similarly, Q3, the upper quartile marker, is the median of the upper half of the data. Well, halfway in between is right in between there and there. So we can see that Q3 is the average of 8 and 9, which is, I'm going to say, 8.5. Okay. Last thing I wanted was for us to compute the range and the interquartile range. Both of these things are very easy to do. What's the range? Well, the range is 10 minus 0, so the range is 10. What's the interquartile range? Well, the interquartile range is where we do 8.5 minus 4 and get that it's 4.5. That's the interquartile range. The last thing I might ask you guys to do is I might ask you to draw a box and whisker plot for this, right? So if we draw a box and whisker plot, by the way, it's always wise to try and draw a box and whisker plot to scale. So if you know that you're going to start at 0 and end over here at 10, sort of try and keep some sort of like scale in mind for yourself, right? So the median is 7, right? So if we sort of imagine if this is 0 and this is 10, maybe this is 5, so maybe 7 should be right here. So 7 is going to go right here, and this is my median, right? My first quartile goes down to 4, so I'm going to sort of draw my box going all the way down to 4, which is Q1. Right? The upper quartile goes up to 8.5, so we're going to go up to, about 8.5 here. Again, this is a rough estimate. And then you just have your lines, your whiskers rather, that are going out to your minimum and your maximum values. Okay? So that's how we represent our data in a box and whisker plot. And in theory, you can tell that, the most concentrated set of data is between 7 and 8.5. The least concentrated 25% of the data is between 0 and 4. So if that means anything, then yay. I've got one more example for us. So in this case, I'm giving you a frequency table. I'm not giving you a listing of all the numbers. And if you wanted to, I suppose you could list this out. You could make the listing 1, 2, 2, 2, 2, 2, 2, 3, 3, 3, 4, 4, 4. You could write them all out in a long list. But I hope you guys will get the hang of this and not need to do that. All right. So how are we going to find the interquartile range? To find the interquartile range, we're first going to sort of need to break this thing in, like where's the median, where's the midpoint of the thing. And so I'd recommend you guys pause the video and think about how you're going to do that. An important thing for you to figure out is what's the total number of data points that I have. If you add up all these frequencies, you should find that it's 20, right? So our median is going to be between the first and 20th terms, right? So if you're looking at 1 plus 20 over 2, that's 10.5. I need the 10.5th term. Right, so what is the 10.5th term? Well, 10.5th, I've got 1, This is sort of 1. This is going to take me from 2 to 7. This is going to take me from 8 to 10. And then this is going to take me from 11 to 13. So my 10.5th term is right in between there, right? It's right in between 3 and 4. So that means that my median is 3.5, right? So I know that my first half of the data, my sort of upper half of the data, is here, and my lower half of the data is below that, right? So our next step is to figure out what Q1 is up here, and then to figure out what Q3 is down here. And again, if you're up for it, pause the video, see if you can figure that out on your own. Right? So in this top half of the data, you've got 10 numbers here, and so since you've got 10 numbers, Q1 is going to be at the 5.5th term. And so again, you can sort of imagine, oh, the 5.5th term is in here, so Q1 is 2, right? That's what my first quartile marker is. Down in this range here on the bottom, we're going between the 11th term and the 20th term. So that's going to be 31 over 2. I'm looking for the 15.5th term. So if you sort of count it out, this is 11, 12, 13, 14... 11, 12, 13, 14, 15, 16. So 15 and a half is in here somewhere. So Q3 is 5. Right? So my interquartile range is going to be 5 minus 2, which is 3. I have a feeling that all of this was really complicated. It's not terribly difficult stuff. I'm hoping that as you guys work through some examples of it, you'll get a chance to see this stuff and see how it's working.